So in this question, like we have to find the minimum paths, right? So what this question says, given an m cross n grid filled with non-zero negative numbers, find a path from top left to bottom right, which maximum minimizes the sum of all numbers along its path, right? Okay. So starting, we have to start from this. So in the example one, we are starting from this one, right? And we have to go to this cell, right? Starting from this cell, we have to go to this cell. And what are the moving options we have? Like we can either move down or right at any position, right? We can either move right or down, right? So if I try go through this way, right? 1 1 4 2 1. So what is the sum? 1 plus 1 2, 2 plus 4 6 plus 2 8 plus 1 9, right? And if I go to this, like 1 1 5 2 1, right? Down, right, down, right? So 1 2 2 5 2 7 7 2 9 plus 10. No, this is an expensive path. I have to choose it, right? Now let's go through this way, right? 1 plus 3 plus 1 plus 1 plus 1. But 3 ones, 3 plus 6 plus 7. Okay, so this is much smaller than the first one that we have traversed, right? So this would be my answer, right? So we have to return the sum, minimum sum, right? So how we can do it? Like again, look at the constraints, right? What is the constraints? Constraint is like again 1 to 200. Like without even practicing how we can generalize our approaches, just look at the constraint, what it is. If the ranges are lying between 0 to 200 or within that, then we must be sure, or our brain must think in that direction, that okay, this is a dynamic problem question, right? We have to use DP here, memoization, tabulation, whatever approach you want, you can apply, right? Okay, so even what recursion, even recursion you can apply here, but since the time complexity would be much bigger for the recursion, if we go through the recursion way, then the time complexity would be higher. Okay, so we'll do this using DP only. So what are the things that we need is, first thing is number of rows, how many rows are there. Okay, so grid dot size, right? Columns, how many columns are there in the grid. Okay, so now we have to create a vector DP general. Now return the solution of DP, right? Grid DP R minus 1 C minus 1, right? Okay, so now this is bottom up, right? Memoization I'm doing. Copy it. So what is the base case, right? The base case would be if I am at the 0th index. Okay, what if I am 0th index? What to return? Right, I equal to 0 and j equal to 0. If I am at this cell, right? So if I am at the beginning cell, then just return the value there, right? DP of I and j, right? And what would be another base case? Another base case would be if that the path that we are visiting, if any pointer or if any row or column goes beyond the boundaries or beyond the uh, constraint that we have given, then we must return 0 then, right? So if I is less than 0 and j is less than 0, so just return what, minus 1. Okay, so we have to return minus 1, right? Yes, okay. And then again, if we go to right, get the paths, right? Grid DP I row on going to left to right. If we are going to right direction, then which parameter is changing, right? Row or column? Obviously column. So I will be saying j minus 1, And if we are going from down, if you are going down, then which parameter is changing? Row, obviously. I minus 1, right? And also the sum as well, grid of I j, right? We have to get the sum, right? I j, then just return, just get the dp table, and in that return the minimum of that right and down. Like these are the paths that we will traverse, and among that paths, whatever the best path, whatever the optimal path that we have traversed will be returned back into this dp table, right? So we'll try and run it. Oh, one thing I did not do it. What if the dp of I and j is visited, right, is not equals to -1, then we should return dp of I and j, right? Okay, let's see from it's returning to, right? You have to get the minimum, right? Hmm. Okay, this is fine. Hmm. Why 2? 2 means that just a second. Let's see what's the error. Okay, so it's giving me -1, right? -1, -1, -1. Okay, so this is the problem, like this line. Minimum path sum. Minimum path sum. Okay, minimum path sum. I can't return -1. I have to return some infinity value there. I minimum, I think that could be the case. It's not given, but okay, the minimum is asking the minimum path sum, right? Let's see if it works or not. Okay, in the same error, right? This time it's actually improved, right? We are getting 5 now. Okay, so I think there is something more error in this. What would be that? Anything I've done like wrong? Oh, grid, right? Why am I returning dp? Hmm. Okay, if I change it to -1, then this will work now. Okay. Let's see. Let's wait for some time. Run it. ऐसे नहीं है क्या फिर? Yeah. That line should be there. That line should be there. Yes, it's asking us minimum, right? So for minimum, if we go out of the bound, then we have to return the maximum number, right? That is, yeah. Now I think I will comment it out or remove it. Just submit it. Yes, it's working. So that's it for this question. If you have understood it, it's well and good. If you have not, then write down in the comment section. I will try to clear your doubts and everything. Thank you, and do the tabulation part yourself and that recursion part yourself.